So just before we go on to solving this exercise, let's talk a little bit about the intuition behind mixtures. So basically, I actually think that one exercise in the book in chapter 2 really illustrates the point behind mixtures really well. So I'll bring up that exercise as an example here. So in that exercise, what we have is a house on the Caribbean islands, and a storm is approaching. And then what they say about the storm, I can't remember the exact details, but it's something like this. They say the storm can have three different strengths, one or two or three. And it has these strengths with different probabilities. So P1, P2, P3. And given a certain outcome of the storm strength, the damages on the house will be distributed a certain way. So the damages on the house, so we call the damages X. So the damages on the house, given that W is equal to 1, is distributed one way. Given that W is equal to 2, is distributed another way. And given that W is equal to 3, is distributed a third way. Now, this means that the damages on the house will be distributed in different manners according to the strength of the storm. For any insurance company, for example, if they're running their business in the Caribbean islands, then what they will observe is the damage done to the house given a certain storm strength, right? That is what they will observe. So what if they want to find the distribution of X just in general without taking storm strength into account? Because maybe they want to start insuring houses in the Philippines or whatever. So how do they look at this? And this is where the formula from the mixture chapter comes into play, because X is a mixture. It mixes three different distributions depending on the strength of the storm, hence the word mixture. Now, what we're looking at here is a so-called finite mixture, and the reason why we call it a finite mixture is because the different cases of distributions that X can have, well, they're discrete. W can be 1 or 2 or 3 and nothing else. And in the case where we have a mixture that conditions on something that's discrete, we can find the density of X. So for example, if X is continuous, then the density of X in this case would be given as the sum for each of the different values that W can take. We consider the probability of that happening and multiply that with whatever density X then takes on in that case. So that is the conditional density. And here the difference between this formula and this formula that we wrote up earlier, well, the main difference here is that in this example with the storm, we condition on a W which is discrete, whereas in the exercise we condition on a W which is continuous. So that was it for the intuition part. In the next video, we will start solving this exercise and doing some calculations.